Another draft physics video presentation, let's call it. Anyway, who cares? Semantics and such. So some Bill Gaedes, over there, first, and then comments, I guess. So Bill just keeps asserting, okay, that no particle model can, and no particle model can, and you have to explain. And I have explained some of this stuff 6 years ago, conceptually. And so, he only essentially picks on dead people. Dead people didn't know it, therefore nobody knows it, or something like that. Even if you do raise your hand kind of in his face and say, hey, Bill, I'm here, he doesn't pay much attention. By whatever standards his radar is. We all have a radar, I guess, of some kind. We all, pick and choose. So anyway, so let's play this. He mentions me, but obviously hasn't paid any attention to me. But anyway, let's play it.
Here someone says, Gary from Draft Physics has a good particle model of gravity. Well, yeah, it'd be nice if this individual can put a, can make a mechanism, can illustrate, can make a movie of
it. So he's saying he's made movies of his stuff. No, he's taken an animation, tied a rope around a donkey's neck, and slid the donkey with the rope. Now, that's not much of an explanation of how your physics works, in terms of how your atom casts these ropes to everything in the universe, and then somehow how it's pull when, if you analyze it, it's actually push, or pushing on the back of the donkey's neck. I don't know if you realize that, but that's how that works. So it's just an example of an inverted push. You've made a hook and essentially pushed something and then says, I'm pulling it. Well, it's not the same. And I could ask a million questions, like how do your ropes know where the center of mass is of the object you're pulling? Because if you don't pull on the center of the mass, it's going to go sideways, like your little chair analogy. It's easier to pull a chair towards you than to push one. Well, it depends on the surface you're pushing or pulling on, obviously. And again, it's this, you have to do the center of mass thing. How do you figure out the center of mass? See, an external force pushing in will always find the center of mass. It's automatic. So anyway, so I have drawn it. I mean, there is a guy who's working on a simulation. I mean, I'm not going to promise anything because I don't want to obligate anybody. He was going to give an effort a while back, and listen that happens in life and all that kind of stuff, and it didn't happen. And so he says he's remotivated and blah blah blah, but no pressure. So maybe there will be some simulations, Bill, some really good ones. Well, better than drawings, but I'm just saying drawings are pretty good, Bill. I mean, I'm making arrows, and I'm showing what happens to the arrows over time. That's pretty much a simulation. It should be good enough. Smart people should be able to get it. They shouldn't need, Pixar or something,
And that'd be great. We would love to see what kind of movie he does, and if he answers all the questions that I just presented. Okay?
Yeah, well, some of them are almost... I'm sorry, oxymoronic or retarded, silly. If you take the modern theory of matter, so it's sort of to the credit of a particle model that what we discovered later about atoms, that they're mostly empty space, fits right in. Explains it pretty well. Why? Some of your why questions. So the fact that they could conceive of it and make it almost work when they didn't even know atoms were atoms, as we understand them.
In other words, you have to explain how the particles go through and also push. He's got to explain that here. And
yeah, it's really not that hard to explain how stuff goes through filters. Some of the stuff gets through, some of the stuff doesn't get through. I mean, there's a screen on the window. Some of the air gets through, some of the air doesn't get through. It's not that complicated.
A lot of these people, what they do is they begin by denying that that's what gravity does. They have to do that because...
I don't know. So he threw me in sort of a category here. A lot of these people, I don't know who these people were. Frankly, I haven't seen anybody who's defends particle gravity, or even a Lesage model who's asserted that it doesn't happen, that somehow the gravity doesn't go through the objects. So I don't even know who you're talking about with this lot. I don't know who this a lot of people is. So that's almost like, I almost think that's a false accusation. I think a lot of rope theorists, believe in Tinkerbell. It seems like there's a huge correlation between rope theorists and Tinkerbell believers. I can make up some accusations if that's how you play the game.
They have no way of explaining it. So they'll say, that's not true. Okay?
So why don't you demonstrate that? Why don't you show me some particle theorist who states that they're not ultra-mundane particles that are and objects' matter is semi-transparent to them. Show me the one who's arguing that.
So they start by denying what is, and therefore they can say, now let me explain my theory to you. And what they do is they just explain it, and they never show a movie of it.
So again, it all depends on what you consider a movie. So I'll draw you some pictures. It's close enough, in my opinion, to a movie.
So the issue is they have to show a movie like I did here, showing how particles go through and at the...
Yeah, well, your movies are not that good, Bill. So again, they're really not that close to reality. You vibrate things and then say you're showing how there's motion in a direction. Well, that's not very helpful. And then to explain magnetism, you have ropes jumping. And you say, there, that's attraction, and this is repulsion. Or vice versa. How so? Your movie doesn't show how that happens. How that makes things really attractive or really repulsive.
At the same time, push. That's gravity. If you cannot answer that question, your particle theory is worthless.
Yes. Well, the whole point of what is a push? Okay, so let's start there. Okay, what's the nature of a push? And the argument is that all of this conversation is really about the absorption of something. You have to absorb a force. That is, the force has to be flung into you through some mechanism. Now, the easiest way to fling something into something, so you have something, and it doesn't have the virus, so to speak, and you want to give it the virus. Well, you have to take the virus from here, and you have to put it inside the thing to give it the virus, right? And momentum is essentially that's the argument being made, is that these ultra mundane things are moving the speed of light, so they're going very, very fast. And when they're inside of something, when you give them to something, okay, this little thing that was going, the speed of light isn't going to go the speed of light in there anymore, because it has to do work in here of some kind. It has to move all the other little bits that are attached. They're all attached to each other, a little bit of a tension between them. So if it moves one of them the speed of light, well, it has to drag all the rest of them with it. So it's a real heavier load. So this thing moves much slower. C minus a lot. Okay, so C spread over 1 million. So, the C divided by 1 billion, little bits that have to go with it. So the speed is reduced proportional to the amount of mass, okay, that you have to drag along, that you have to continually exchange the virus with, to put it one way. So the simple idea to understand is that, okay, so Bill doesn't believe he doesn't believe the standard model is at all correct. So maybe he doesn't believe in electrons and protons. I don't know how far he's going to go. But the standard model basically says is that you have the electron, we'll put that with an X, and just to avoid the color obligations, and the proton, we'll do a little circle. And the idea is, this is the nature of atoms, is that there's this empty space in them, but these are the bits that you have to move. The electron and the proton are the constituents of the atom, so whatever your atom is made out of, it really just doesn't matter. And that, when you move that thing, okay, that takes work, and continual work. These things don't keep going through space, so we have evidence of that. You just don't hit one of these things with one little photon, and it travels forever and ever and ever through space and never to stop. That's not what these little elemental bits do. Now, these big atoms can do that, but they don't do it very efficiently. So if I can have 10 meters per second, I can sit there and accelerate it at that speed. But guess what? After 1 second, it's not going 10 meters per second. It's going like 8 or 7.6 meters per second. So somehow we lost 2.6 meters per second worth of velocity. That didn't happen. That somehow was lost through this inefficiency of this acceleration process. So matter doesn't accelerate perfectly, cleanly. It's a process, and the process is arranging these little bits of matter in such a way that the energy is now trapped between them, and so they're perpetually pushing in a direction so they can keep going through space. So nuclei, you can shoot through space. You can make a cosmic ray blob and shoot it through space. But you can't shoot these little electrons and protons through space. They can't travel billions of light years through space. Only the photons and only these big hunks that are more complex can. But anyway, that's a little bit more than you need to understand the simple idea of the gravitational model. So obviously the point being is that most of matter is empty space, and so this force is very transparent, very goes right through things, and like light goes through things, and it goes through for a reason, and the reason is it's not at a frequency. Okay, it's not at a frequency, and to be effective, it doesn't have to kick an electron a certain distance. It doesn't have to do any of that. These little blobs can get right through pieces of lead. They can go right through everything without hitting anything in any kind of critical way, in the sense that the force they imply does give an electron momentum, but that momentum will be consumed, okay, by drag, and so it will give back the force in the opposite direction. See, this will be a reflection, and then it'll move, and then it'll be slowed down and stop, and when it stops, it gives back the same thing it consumed over here. So the force can go right through even the electron, in a sense. The electron can have momentum for a period of time, okay, and then drag, because it's moving into more force than it's behind it. Drag will slow it down, and when drag does, it will release back the energy it consumed. So when matter stops or starts, each one of those stops and starts, each movement represents occupying a force. So the force is inside of it. So the simplest idea is that the force is, in a sense, trapped, occupied, possessed by something. So the idea is the force is moving the speed of light. The matter bit is big. It doesn't move the speed of light. The force goes into the matter bit in a trap, stays in there. Its initial momentum is kept, essentially, and the matter bit moves much slower, which means this force didn't get where it was going. It was supposed to be over here at time t2. It was supposed to be, well, you can't see time t2. Can you see it here? Yeah. All right. Well, I'll just redraw it. I'll restart the movie. All right. So you have your force. I should start over here, right? Moving the speed of light. Okay. So there's a little bit going C. There's a clump of electron. Okay. It goes into the electron. Equal and opposite reaction. It's a little bit leaving. And now this has a bias in a direction, and it's moving this way. And the idea is this doesn't get here. Okay, this is T2. This is where it would have been. And where is it? It's still in here, moving this thing dead slow. So this thing's moving really slow. T2 is waiting. It doesn't get it. So this is essentially the Earth over here, whatever the other body is. And it isn't going to get hit with something in its face that it should have got hit by, because there's something that consumed the motion. Alright, so the motion went in really fast. The motion's now really, really slow. Okay, so the force has been occupied inside the thing going really slow. And it doesn't get where it was going. And where it was going to balance the force for somebody else. Now their force is imbalanced, then they're going to move. And their movement means they're going to absorb force. They're going to have force do exactly the same thing. They're going to have force jump into their electron boat, so to speak, be occupied, and their mass is going to move slowly, because all the electrons have to sort of push each other, and all the protons have to be dragged along, and the whole atom has to be dragged along. So when one bit moves, all the bits sort of have to eventually move along, because their balance position is now changed. If I'm in a balanced position between guys shooting from me at the left and guys shooting at me from the right, and one of them moves a little closer, well, I'm going to get hit by more bullets, so I'm going to tend to move in that direction. And when I move in that direction, I'm going to get closer to this other guy, and the rebounds off my bullets are going to hit him, and he's going to get pushed away. So the pressure moves through the object, okay? And that makes the whole object move. So even though I only moved one electron, I essentially moved all of them when I moved one of them. And so they all move, but they all move much, 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 much slower, because the speed has to be divided into all of that mass. And so that's the basic idea. The force technically doesn't have to go all the way through, but it certainly does in terms of the size of the objects we know of now. The limitation on this theory would be that, black holes are probably nonsense in this typical description of one. That the force has a density, there is an amount of it in the universe, and once you have an object big enough to absorb all of it, okay, every bit of it gets absorbed before it gets through this big, huge, dense thing, then obviously you couldn't have more gravity by making this bigger, because you can only have so much force to absorb. And once you've absorbed it all, and that's it. So gravity could only get to a certain limit, and that's it. It can't go any higher. And that's probably why the universe doesn't have suns that are 500 times bigger than other suns, or whatever the thing would be, 1,000,000 times bigger. That's why the universe isn't full of giant suns instead of galaxies, is because of this breakdown gravity, breakdown mass. So anyway, so I think the idea that it's transparent, that only some of the force is absorbed by, especially light masses, right? So like masses like a feather, where the atoms are further apart and there's a lot fewer of them. Obviously, the force goes right through most of it, because there's very little stuff to hit, and the more stuff you have to hit, the more boats there are to jump into and get trapped into. Then the more force that gets trapped, the more force. That's perfectly consistent with the force equation, in the sense that it's perfectly consistent in the sense that this is just a force. This is just telling you how much stuff was consumed, how much stuff got occupied, and so it's really just telling you that's the only connection between the masses. But the only thing that's creating the gravity is the thing that moves. The movement is creating the gravity. And so what you have to really understand is that when the Earth is stationary, but we know that the Earth inside has got lots of movement in it. And all of that movement has to be constantly fed because of this drag subject. Alright, so you have to keep feeding the movement or it stops. The electrons and protons will not keep moving unless they're constantly hit by force they absorb. So they're constantly consuming force, okay, as they move. And so you have this consumption in one direction, and you have a consumption in this direction, and that's what holds people on this side of the Earth. And on this side is the fact that this one notices the stuff that got absorbed going this way, and this one notices the stuff absorbed this way. So this one feels the lack of pressure here because a bunch of force that should have hit him in the feet don't hit him in the feet. It got absorbed by moving the mass. Okay, and likewise for this guy over here. And the trick is that once you've blocked the force, you've blocked all of its implications. And so part of the implication to understand is that electrons are repulsive for a reason, that they're radiating a force that they're reflecting a force, right? The external world pushes in on them constantly from all directions, and they essentially, because of equilibrium, reflect it back. That's the way it works, fundamentally. And so you can just see the obvious implication of that is if they are in the way of each other, they're going to obviously block this part of the force from each other, and they're going to end up absorbing it, and they're going to move into each other. But again, that's not how the gravity you fall into isn't the gravity you make. So I don't need to have an interaction with the Earth. I mean, I can be moved to any location on the Earth, and I don't need to be having a personal relationship with the gravity for the gravity to already be there. The gravity is being created by the stuff, the mass that's already on the Earth, and this mass is pushing in, and this mass on this surface is pushing in, and this is very high pressure in here, very high pressure. Okay, so the deeper you go, the more the pressure, because all of this stuff still is accelerating. It's still trying to go 10 meters per second, and it can't. It's being stopped because there's stuff here doing exactly the opposite, and so it creates a balance in the two pressures. And that gets more and more intense as you go deeper. Then you're starting to change the balance, because you have now this mass against this little bit of mass, and so now the pressure balances become exactly the opposite, and obviously this pressure is so intense it'll even push in from the sides. But anyway, I don't want to get into that. So anyway, that first argument, that how is it transparent? Well, it's transparent because atoms are empty, a lot of empty space. I don't think there's much empty space as the conventional model has, in how small they've made the electron and proton. I don't think they're as small as they think they are. But they're clearly charged elements in relationship to each other in tension. So the proton and the electron are attracted, but the electrons are repulsive to each other, and there's a tension that builds up in atoms based on that idea that you can't really move this forward without these things repelling more. So the closer you get, the more reflections there are, the more repulsion there is. So even though he's attracted to this proton, wants to go there, he can't go there, because to go there means he has to get closer to these repulsive elements. They won't allow that. They'll push back, and they'll accelerate back, and it won't be able to do it. So this is an atom. An atom is tension, okay, and that's why it's held together through tension between the charges. And so I don't know what your idea of what charge is, but that's what charge is. And that's what connects the little bits to each other. So I can hit one little bit, and that one little bit, that one electron, will affect all the other electrons and all the other protons in solid matter. That's what makes the matter solid. It's the fact that all these little bits are in tension with each other. They're attracted and repelled in some sort of balanced condition. So again, the simple argument is that the force, which is and the energetic part of it, is just the imbalance in it. So we call it energy when there's an imbalance and something is forced to move in a direction, and it's forced to move. The electrons don't move on their own; they move where they're forced to go. And so the simple idea is if you have two objects, and the two objects will hit as much force, okay, as they have mass. Obviously, they can't stop a force if they don't have atoms to stop it with. So depending on how many electrons they have and how many protons they have, that's how many bits of force they'll get blocked, and the rest will go through, okay, unencumbered, except for the fact that it has been diminished now, because these little bits have all been moved. That means they're going to spread their energy with all the bits moving this way, and the bits moving that way, and the bits moving all the other ways they could be moving. They have to drag all those bits with them through the tension process. So this moves very slow. The force that was here, that should have been here, okay, is stuck here, going much, much slower. And that simple idea of understanding why there's less force here, and therefore the object will move in the direction of the lower pressure. There's less pressure here, this object will then absorb more hitting. It'll get more hits from this direction than it gets hit from this direction, and obviously the implication of that is it's going to end up in a new position closer to the other object. And this just feeds on itself and blah 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 blah. But again, that's not the gravity you fall into. The gravity you fall into is being made by the stuff already on the surface of the earth. The ground below me is blocking. That's the place where, that's the thing forcing me down. And it's blocking whether I'm here or not. You know, it doesn't matter. I don't need to be here for the ground below me to be accelerating at 10 meters per second. It's a little bit more because it's closer, right? So it's accelerating a little more than 10 meters a second. Right now it's doing it. But it's also pushing back up, right? All of it has to be doing both things. Anything on the surface of a clump of matter is doing both things. It's going in and then it's getting pushed back out. That's the nature of acceleration. That really should be enough. Yeah. So it's not a movie, but close enough in my opinion. But all your questions, all your little superficial and trivial claims against particle theories working are just that. They're superficial and trivial. And if you gave it some thought, they're perfectly solvable, and the evidence supports them. Again, the evidence supports the idea that electrons don't have perpetual motion. You can't take a clump of electrons and throw them in empty space and expect them to just keep going, because they won't do it. And neither will protons. In an accelerator, you worked at accelerators, you said, or with vacuums and such. You can't put them in a nice, clean, frictionless magnetic field and have them just keep going around and around for years. You can't. They lose their momentum. They're not wrenches in space. Electrons aren't matter. Electrons in relationship to protons, okay, is matter. And that has different properties and different abilities than what the elemental bits have. Alright, that should be enough. So we'll see if we get a response. We'll see if we can encourage more elaborate conversation, more extensive conversation on the nature of force, and the fact that pull has huge liabilities as a concept. Yeah. Anyway, I don't think he says anything else.
Okay? And that's why nobody in officialdom, in the official world of mathematical physics, pays any attention to any of these dissidents. You have to keep in mind that.
So he's just dissing them. He's saying that they're not paying attention to us because of this theory. No, I think rope theory would get you people not paying any attention, especially when you animate it with pulling donkeys with push. When you make those kinds of gross errors, you make dissidents look bad, Bill.
The mathematical physicists have abandoned the real particle hypothesis.
Yes, exactly. So that we know. So don't pretend that that's a particle model, and just recognize that again, you've made these superficial debunks of Lesage gravity, and you did it based on parts of it that aren't even consistent with that theory. I mean, both Fadio and Lesage had the idea that whatever's in matter, okay, this force misses it somehow. It does go through it. That's why they call them ultra-mundane particles, meaning they're just so little, so tiny, that they get through the cracks.
That's the paradigm shifted in the 20th century. What shifted was they no longer deal with real particles. A lot of people don't know that. They keep drawing the little ball, and they say, look, this is a photon. No.
I mean, yes, obviously. I mean, the Higgs boson, all these things, they're all forces. They're not frickin' particles. So they've broken it in the sense that, I would argue that they could still quantize these things. So, there's still a quantizable clump. But what they even think a photon is, again, they haven't even explained. They draw this wavy line thing, but they don't even talk about how long the wavy line is. They have no concept that it matters whether it's 3 little wavy lines or whether it's 17 or 500 or 600. They give you no explanation how this photon can be a whole bunch of stuff or a whole little bit of stuff and somehow have the same amount of energy. Even that doesn't make any sense. So they don't tie up any of those loose ends. It's really sloppy physics.
That's okay for pictorial representation of trying to explain to someone, what you're talking about, your mechanism, but you cannot believe that you're dealing with real particles anymore. Mathematical physics in its entirety has abandoned.
Well, it's not really true, okay? Because mathematical physics, you could define it as starting with Maxwell is when it really got mathematical, in a usability sense or something. I mean, obviously Newton was mathematical, but it was, like I drew the equation. It's a simple equation. So when you get into the idea of Maxwell, and Maxwell has the rays, okay? I mean, that's the idea, and then quantum mechanics is just say, yeah, the rays are made out of quantizable clumps. It's a clumpy kind of energy in the ray, perfectly validating essentially what I'm arguing.
The physical particle, the corpuscle. They're doing it with concepts. The particle is not a particle. It's not a little ball. And all these dissidents, they're still 10 steps behind quantum because all these people are trying to do it with real particles. You can't do gravity with real particles because you have to explain how it goes through an object and at the same time pushes it.
Well, again, that one is just so easy to explain. It might have been hard for somebody to explain 300 years ago, but now that we understand charge and we understand that atoms are made out of, like solar systems, there's less real stuff in it than there is, there's more space than there is Earth. A lot more space than there are Earths. And that model of the atom, it's perfectly understandable how some of your force will hit the Earth and Venus and Saturn. But if I threw a bunch of asteroids into the solar system, we can understand that most of them won't hit anything. And the ones that do, the consequence will be the planet moves a little tiny bit. The asteroid was going 400,000 miles an hour, but the planet's just going to go a little tiny bit faster. And that's perfectly consistent with what I'm arguing. It's perfectly reasonable. And you're saying somehow it's unreasonable to understand that if I throw a bunch of asteroids into the solar system, that most of the asteroids won't hit a planet. No, that's perfectly reasonable. And it's perfectly reasonable to understand that if I do hit, the ones that do hit the planet have the consequence of causing the whole solar system to move in the direction that the asteroids were moving. That they'll give the solar system momentum in the direction that the asteroids were moving. And that has a consequence. If there was another solar system and the solar system was repelled each other, you could certainly understand that if this solar system moves closer to this one's going to move away. Just not that complicated, Bill. Alright, so enough of Bill. Let's see if we get a response. So I didn't get anything from the Chappelle folks, Franklin, who their Saturday chat was just so irrational. They were getting on evolution and making proclamations about how they don't see how speciation can happen and all this, and they're all creationists anyway. And Franklin seems to be something like a rationalist, but I don't know. He's indulging in like it's somehow too mysterious. Our evolution doesn't somehow work, that somehow you need something else, and he implies some kind of intelligence is involved in evolution, and so it's almost like he's heading for some kind of religious bullshit. And what other subject did they touch upon that was, I mean, it was so stupid that you're almost saying, these people are hopeless. So anyway, I mean, all I can do is respond. I can't force people to have the integrity to defend their accusation. So, Bill, if you're going to make accusations that I can't explain it or I haven't explained it, then you ought to back it up. All right, because I have explained your critiques have been answered. So, whatever. On to the comments. All right, Jerry Perry. If I remember it correctly, Ben Space was a thought experiment from the beginning. Well, everything starts as a thought experiment from the beginning, but clearly, having a concept of mechanism is often got to be simulated through the imagination. I mean, I can only draw you a picture. I can't really show you a videotape. So in that sense, they're all thought experiments. Just an idea, a what if. Yes, everything starts that way. What if space is bent? So anyway, obviously that's where Einstein started, but then he said, what if time is also is following the same contours as this bent space? Which doesn't, it just, the only thing that helps to do is make the subject so confusing that you forget that the idea is stupid because it's two-dimensional. You can't bend anything in 3 dimensions and it doesn't make any sense. So, yeah. So by putting space-time together, those words, they are such different concepts that it creates enough confusion where you allow it to be, well, maybe because I can't understand it at all. I mean, I can't smash those two things. They're too different. I can't make a platypus. I can't smash the duck into a raccoon or whatever the hell it is. Anyway, it seems to work well as a model, so Einstein decided to stick to the idea. Well, that's really not the history. The idea is that he thought it was a solution to explaining something like a mechanism, but it's just such not a mechanism. I mean, just to make a claim, oh well, space is in some invisible way bent. It doesn't give you a mechanism. It's totally inconceivable from my perspective. I can't understand it at all. It's just, all he's really saying is that if I put a piece of matter in space, somehow there's a convergence of space. The space is sucked by it, and the space drags the matter with it. And that's how they mathematically deal with it, as a fluid dynamics. They teach the subject as if space is a fluid and you can move it. And when you move it, the stuff moves with it. Gravity is an extremely weak force, so that's just more of their rhetoric, okay? You can make a claim like that. It's moving the fucking Earth, okay? It's forcing the Earth to make, in 1 year, it's forcing the Earth to make 4 90-degree turns. Okay, that's not a minor thing to do. I'd like to see you do it, fuckface. Let me see you push a planet, 90-degree turns. Let me see you do that. It's just a stupid thing to say, in my opinion, to call it a weak force. It's exactly the same force as magnetism. Obviously, it's just that when you take away the segregation, when you take away the electron on electron force and the proton on proton force, the strong repulsions, it's a much weaker force than that force. But that's because it's diluted. Purple isn't as strong as red and blue. Still, it works over almost endless distance. So again, that's never been tested. The endless distance would be the same argument you could make with a light bulb. Now, theoretically, I could take a light bulb and shine it in space, and billion light years away, I might get a photon, right? But the argument would be, there would be a ton of empty space where no photon shows up for 1 trillion years. An actual 1 trillion years have to go by before 1 photon hits. So, yeah, it's theoretically there at the speed of light, though. So it takes it the speed of light to get there. And it could take 1 trillion permutations, like you could wait for 1 trillion photons before one finally gets to you. So not only does it take a long time for them to get there, even at the speed of light, their irregularity is going to be, preposterous also. So the likelihood of getting hit at great distances is really, really tiny. Anyway, you would think that only a strong force has long reach, but with gravity it's different. Well, obviously, again, the charge thing, Maxwell's equations have 3 different R's in them. R, R squared, and R cubed. So when you dilute the force magnetically, it's a weak force in terms of it doesn't have very good traveling distance. So dipoles at a distance don't look very strong, okay? Where the monopoles are stronger, and just trying to, the R thing really has to do with more size proportions. So if you create an effectively infinite surface on one side by proportion, the proportions of the two things are so uneven that any radiation off this will be hard for this not to see it as an infinite plane, and therefore it's going to have an R rule. Or no, it'll be 1. The infinite plane is the one. Well, it doesn't matter. I mean, it matters when you're talking about that, but I mean, it doesn't matter for the purpose of answering this question. You would think that only a strong force, weak but never ends. The easiest way to explain this is that mass distorts the space around it. I think it's the silliest way possible. It doesn't say anything, doesn't explain anything. Distorts what? Distorts nothing. Oh, that makes so much sense. No, it doesn't make any sense at all. Models are never 100% correct, but if they work, they aren't completely wrong either. Well, that's just words out of your mouth. The model of angels works, but it's completely wrong. Completely wrong. I mean, there's no angels pushing the earth into the sun. So there's lots of models that are just complete bullshit. And I say your bent nothing is complete horseshit. Has nothing to do with the reality. There's an actual mechanism, a physical structure. There's a Rube Goldberg machine here, made out of pieces, made out of functional parts that have properties. You're saying there's something that has no apparent properties except that it bends in some way, and somehow electrons know it bent, and so they know they have to travel a bent path. It's just invisible man horse shit. You say that's the easiest way to explain. Well, yeah, that's God is the easiest way to explain our existence. It's not the smartest way. So, yeah, fuck you, Jerry. All right, anyway. Masterpool. Can you delve further into how elemental identification works using spectroscopy? How do astronomers know what types of atoms, stars, nebula are made of? Why does light source emit bright lines in a region unique specific? Okay, why do corresponding atoms absorb light? Absorption patterns. Okay, I'll go through a brief on it. Then reread it light back and shadow bands located in the bright lines were. Okay, you have clarified the obfuscation in popularized science notions of light essence as a wave. Okay, now whenever the subject of light as a wave is postulated on popular media, I have to ignore that. I don't know why you would ignore it. You just recognize that, they just don't understand that it's clumps at a frequency. Like the idea how space can be bent. Well, obviously that one is it's just such a piece of garbage. You can throw that one right out. I mean, they have the idea of a photon, right, in the sense that it's stuff, and it's going in a direction. They have that much of it right, but calling that a wave is just kind of silly. I see you making progress in explaining atoms and forces in these videos. Occasionally surprised, I think I understand what you have explained. Okay, good. All right, so spectrum is just, I guess I have to use green because everything else is broken. Well, maybe the blue will work now because I did alcohol a little. All right. So, spectral lines. Here you have, I always like putting infrared at this end and ultraviolet over here. So you have this idea of frequency, okay, and this is further apart, and this is closer together, okay. I didn't think it was that far out. Yeah, it is. All right, well, I have to move this closer. Ultraviolet. Okay. Not all that visible. All right, and so the idea is that everything everything reflects energy. And so that's your admission. And when you're reflecting some of that energy, you're absorbing it and then re-reflecting it. So that would be your absorption. So the idea is that there's little bands of emission. So this would be very bright, and then it would be a little bright line here. So this would be very specific wavelengths, like 500 nanometers. And so 499, there's not much, and 498, there's not much, but 500, there's a whole bunch. And then, at 300, there's a whole, well, that's the wrong way. This would be 800. So at 800, there's a little band, there's a little band, there's a little band, and a little band. And they'll be at different distances. And you could have 4 or 5 of them in one place. All right. So those would be the ones that are emitted. That's what's reflecting to the universe, or that's what it's producing because it's hot, and it's producing this pattern. And absorption lines would be just the inverse in the sense it'd be dark places, places where there was nothing was getting absorbed. So the lines would look the same. They're just the opposite, what you absorb and what you emit. Now, I have to give you the simple answer because who knows exactly how the thing functions. But the idea that these are frequencies, all right, and that the frequencies have something to do with not only the energy going into, say, an electron moves, right? So if I hit the electron, and we understand the electron's under tension, so if I hit it at a specific frequency, you can see that, right? All right, so I'm gonna hit it, and so the electron's gonna move to this location, let's say. But it also has a tension, that is, it has an attractive force. So it's going to try to move back. And so if I hit it at a certain frequency, it'll move back a little bit. And then I'll hit it again with my frequency, and it'll go a little bit forward, but then it'll move back a little bit again. And so it will make progress, but depending on the frequency, I can make it make more progress. So if I hit it with a higher frequency, that is, things closer together, it won't be able to rebound as much, so it'll go a further distance. So the electron will go, instead of going this far, it'll go this far, right? And so that's the frequency in, can create more action out in terms of the electron will go further with it. I could hit it with the same number of these little things, but I'm hitting them in at a speed that's faster than the speed it can rebound, and therefore it goes further. And the idea would be is it's going to decelerate now and go back to where it was. And as it decelerates, the same process is going to take place in the sense that it's going to absorb energy from the field. So depending on how dense this energy is, and depending on how fast the electron's moving into the field. So you have two factors. You have what's it running into. Okay, as it's going into the field, it's now moving. So now it's going to hit more stuff in front of it than from behind it. It's going to make those exchanges. Those exchanges are going to mean it's going to start slowing down first and then going the opposite direction. And as it does that, as it slows down and goes in the opposite direction, each time it absorbs a piece of energy going this way, it reflects a piece going the opposite way. So depending on how much energy is between the atoms, how much pressure is between the atoms, essentially it's going to be the field pressure of the electron. So the more field pressure, that is the more pressure between the individual. Oh, now I'm way off the page, sorry. Yeah, that didn't work. I gotta remember to stay close. Alright, so I'll redo a little bit of that, but not the whole thing. So the idea is that you get the electron to go further away, and its velocity will matter. But what's going to matter is you have to understand there's an atom, okay, and this stuff that the electron's doing is happening in the context of its relationship to the bits in the atom. But the atoms are also in relationship to each other. Okay, so these electrons are in relationship to these electrons of the other atom. So they're also creating the atmosphere or the field that this stuff's in. So this stuff is in the field being created inside the atom, and it's also in the field being created by the outside of this atom. And this group of atoms is also creating a field with the other groups of atoms, changes in the field. So all of those fields are going to influence how fast this electron decelerates, okay, at what rate the electron's going this way, okay, and now it's going to start feeling the pressure, the greater pressure it's moving into. It's creating more pressure by moving in the direction it's moving. And now it's going to be making the same exchanges it was made to be accelerated. Now it's going to be making those same exchanges to decelerate. And as it decelerates, it's going to shoot off a bit. And then it's going to decelerate some more and shoot off a bit. And then decelerate some more and shoot off a bit. And the rate at which it decelerates is going to be decided by the tension between these atoms. So really what these lines are is just representing that when you do kick an electron out, so to speak, or out of its position, that what's going to decide what frequency you're likely to get is going to be the tension between the atoms. And so specific frequencies of deceleration are going to be more likely than other frequencies of deceleration based on the pressure between the molecular tension. The molecular tension is going to have an effect on the deceleration rate and the reacceleration back towards the proton. And so that's why you get these specific lines, is because they're a representation of the molecular tension. It's probably enough. I mean, it's obviously all of this stuff, the mechanism is simple, but the density is complex. You have a bunch of little bits in the atom, and then you have a bunch of little bits in the clumps of atoms, and then you have a bunch of, and then when you start talking about crystals and all the other stuff, there's layers, and all the layers matter in terms of all the layers change the properties. So, but that's just basically all it's really about, is accelerating electrons and decelerating electrons, and that decides what you get reflected and what gets absorbed to cause the momentum. The absorption is then causing the electron to move. The reflection, the emission, is the electron moving back. Okay. Yeah, I think I was fair enough to it. Okay, LOL, no mechanism and no proof. That's on a Ken Wheeler video. We don't know who you're talking about, me or him, and you don't say anything. I mean, clearly Ken Wheeler doesn't have a mechanism. He just says things hyperboloid. So it's like saying bent space is bent. It doesn't say anything. It's useless jargon. It's not a physical explanation. All right. Clearly thinking through. Sorry, I should have explained why I said local universities. It doesn't really matter. This whole argument that somehow I have to have a personal relationship with somebody to have a conversation with them in the internet age, it's just nonsense. The local is archaic. It is. It's just archaic. Okay. It's you've been gapped or something if you think it matters anymore. It can't possibly make a difference. I call somebody who lives 50 feet from me. What's the difference? I call somebody in California. I mean, it just can't make a difference. A local professor is likely to be a lower salary than someone at MIT, so may respond to the money incentive you have offered. Yeah, I know, but I'm getting less and less credibility as I go down the scale, right? So what am I buying? Am I buying somebody who has a reputation they're afraid to have tarnished? The whole idea is to knock down the mighty, not to knock down the weak. You wouldn't remember Davy and Goliath, if Goliath was a midget. Also, they may be willing to meet in person. Again, I just couldn't give a shit about any kind of personal meeting. But anyway, which might be easier conversation than written communication. Why would I do written communication when I know how to do video and I know how to do live rooms? Why would I waste my time with written communication or live chat? And why would I do even live chat? You really don't get it. You're watching a video and yet you think the internet is PDF files and chat. Anyway, over the internet with bad connections, interruptions, etc. It's really not that difficult, frankly. Yeah, there's some technical issues, some technical vulnerability, but as millions of people demonstrate every day, it's really not that hard to do. All right, and the only thing in the way are the spammy pieces of crap out there who are allowed to interfere with everything that's done. I mean, I'd be doing live rooms if it wasn't for the fact you can't make them open rooms anymore because they get sabotaged by malicious assholes. So you have to just do interview rooms or something. It's all a bunch of donut farts. Well, that's just useless crap, but yes, whatever, fine. Just superficial commentary isn't very useful. Okay, Jerry again. Thanks for reading my comment. Well, you might not be too grateful now. I don't hate the guy. Well, that's your bad then. I mean, he really is a horrible, all this misdirection, stuff he knows, like I said, that he doesn't tell the people he's talking to. He's talking about light being bent when he knows the LED light is coming from perpendicular to the LED that shot it. Okay, the light you see is a perpendicular reflection from the LED. So he knows what one LED does, and he knows what one LED produces. And yet he's talking about some bent light. There's no light being bent. There's no laser beam of light that another of the LED is bending. So it's obviously a reflection. The light's being reflected. And what's it being reflected off? Well, it's being reflected off the little tiny pieces of crap that are in the ferrofluid. Well, I'm just saying he knows all that crap. So he's clearly a propagandist. So, you should hate propagandists. Propaganda. He can be funny and has good sides to him. Well, frankly, they're very hard to see because all I see is an insanely obsessed and aggrandizing pile of crap. Could be worse. I don't know how much worse. Frustrating that so many take him seriously. Well, so you can see the frustration that he's just, that's the blind leading the blind. This is nothing but a disaster. Ruins our whole democracy in a way. When the idiots are allowed to be made more idiotic. But what can you do? You could argue against it and say it is worth hating. Can't change others. What do you mean you can't? The more silly nonsense. What's the whole point of making videos or talking at all or doing anything if you don't have any prospect of being able to defend something? I mean, lawyers shouldn't bother going to the court because they're not going to be able to persuade anybody of anything. Fuck you. Best to focus on your lawn. Best to go fuck yourself. Do the things you feel right for you. This babble, baby talk. Fuck you. I mean, that's just such nonsense. Better not to try, better not to do anything. Fuck you. I'm at the point where I realize I don't have endless time left. Well, so that's your problem. Just turned 50. Well, so what? I'm going to turn 60. So I need to decide what to do when I grow up. Probably should cut down on YouTube. Yes, cut down on making comments that are just totally useless, cop-out jabber about nothing that don't provide any useful advice. Thank you. Fuck off. Yeah, I mean, that's just so fucking useless. Stop trying. Fuck you. Ken Wheeler's an asshole, and it can be demonstrated to people. You can show them the evidence if they're willing to listen. And all his viewers are dumbasses. But, there's people who are dumbasses in stupid ways where, they just kind of think they know what they're talking about when they don't. And you can humiliate them. And then they'll say, oh, wait, wow, I was really wrong about that. What I want to say is that an electron, thank you, Gary, okay, a point or a sphere is kind of radiating a negative electric field and only a negative electric field in all directions. No, it's radiating both. The point is one is a deflection and one is a reflection. So you can sort of understand the difference between a reflection and a deflection. And you can understand that when you put those things together, one thing is deflecting it and one thing is reflecting it. You can sort of understand that, well, reflections could get trapped between two things, back and forth, back and forth. And if the other force is getting deflected, then it could never get trapped. See, I mean, it's kind of easy to understand. Come on. When an electron moves, it creates also a magnetic... There's no creating a fucking field when it moves. It always has a field. It always radiates the same stuff. The Earth doesn't have a different temperature when I put it in a different location, okay? The Earth isn't radiating something different when it's going around the sun. It's always the same fucking Earth. All it's doing is moving where the fucking Earth is and where the heat off the Earth is going. So that you could say the heat profile of the Earth is the heat profile of the Earth. If I move the Earth, the heat profile's in a different location. That's all you've changed. It doesn't change anything else. So again, reciting this old crap, this bullshit about how electrons do something different when they're moving. No, they don't do anything fucking different when they're moving. Alright, when an electron moves, it creates a magnetic field, which is just absolute horseshit. It's a fucking monopole. It can't do anything. So if you have an electron in space and there's no proton around, there's no fucking magnetic field, obviously, because you're missing the south pole to the magnet, you dumbass. I mean, how many times do you have to go over this shit? Alright, which has a north polarity in one direction and a south polarity in the opposite direction. Well, an electron doesn't have a north and a south pole. There's no polar fucking electron. It's a mono fucking pole. I mean, I just don't know how people can put this in their brain. They actually have a model of the atom and the electron. Well, the electron isn't an electron. It's really an electron and a proton, or it's really a plus and a minus. It's really, no, it's supposed to be an elemental bit. It's supposed to be something we can't even reduce to anything else. How the fuck can it have a north and south pole? I mean, how the fuck can you take something that's got charge and then say it's a dipole? How can it be negative charge and then be, well, it's also positive charged? No, it isn't. But we cannot find or theorize a particle that radiates a north field in all directions without radiating a south field at the same time. You can't theorize and you can't understand it. Well, Maxwell could. Maxwell could understand that there's a negative charge and in all directions in 3 dimensions it's radiating a force that's always repulsive to another negative charge. That there's absolutely no sign of anything positive between 2 electrons. No sign of any positive parts at all. They're completely negative, completely repulsive, and the closer you put them together, they create intense energy, in terms of the disproportion in the pressure. So where the fuck do you say you cannot theorize? It's fucking Maxwell theorized it. Even though he was an etherist, he theorized the idea that it's a radial force coming off of these objects. Where the fuck do you get this idea that it's stunning to imagine a charge as being a charge? I mean, that is, it's negative all the time. It doesn't switch to positive, negative, positive, negative. It doesn't do any of that crap. Where do you get this crap? This is just so frustrating. You just made that crap up. But we cannot find or theorize a particle that radiates a north field in all directions without radiating a south field. Where did Maxwell suggest that exists? The positive electron, so to speak, the positive negative charge. Where did he draw a picture of a negative charge that has a positive charge somewhere inside of it? Where? Therefore, Maxwell stated the magnetic monopoles does not exist. Again, Maxwell stated that because he didn't know what a fucking atom was, and he didn't know what a fucking electron or a proton was. So don't sit there and tell me that, oh, well, it's inconceivable to Maxwell. If Maxwell was alive today, he'd be saying, fuck, what was I talking about? Obviously, electrons and protons are perfect monopoles. You put them together, they'll behave just like a magnet. If I could take a negative charge and a positive charge of, say, 100,000 volts, and I could put them right next to each other, and I could make another one over here, the two of them would behave just like a magnet. They would turn, they'd do all the same things, attract really intensely, repel really intensely. They'd do exactly the same thing magnets do. Exactly, not in any way different whatsoever. In every way identical to the behavior of magnets. How do you not know that? Alright, perv action. The periodic table starts with hydrogen, helium, and goes all the way up to iron, radium, whatever. Human-made ions, right, whatever. Among other things, the table specifies mass and prevalence in nature. Well, obviously the mass thing is kind of interesting. Prevalence in nature I don't think is as consistent as you're claiming, but whatever. Least massive is the most prevalent and vice versa. I don't think that's true. I think helium, there's less helium than there should be. So I don't think they're in perfect order by abundance. Because there has to be hydrogen or helium to be formed, and usually lots of it. I have to think about it for a while. It's like lithium. There probably should be a lot more lithium than there is. But anyway, the other elements are proportionally hard to make, so end up happening a lot less. I don't think that's true. So I think some of the elements probably they're all made of hydrogen, you could argue. And the argument would be is if you had square blocks, it's easier to make, like you put 4 of them together, you make a new square, right? But if you put 5 of them together, that's kind of a lumpy shape. It's going to be harder to make something out of that lumpy shape. So I can make something out of the nice square shapes, but I can't make a new symmetrical thing out of the weird shape thing. So the derivatives of the less consistently shaped objects probably have fewer derivatives. I just don't think this is. I don't think you have statistics to back this up. I would say as a generalization, it's true. The simpler elements there's more of than the heavier ones. Yes, that makes sense. But I don't think it's in the periodic table as some sort of exact order. The other elements are okay, whatever. That's why a prevalence of graph based on common observation shows tons of hydrogen, helium already pretty rare. Helium is already pretty rare. Anyway, I don't know where you're going with this. A graph from element to element shows a very steep curve. Do you think there to be a similar chartable distribution in radiation on the light frequency spectrum? You want a periodic table of light frequencies? I would say obviously there is a distribution in the sense that the heat is going to decide distribution in a sense, right? The tension between atoms is deciding the deceleration rate of electrons. So you can argue that you can vary these spectrums by changing numerous variables. Ultraviolet light being rare and high frequency like radium. I'm arguing ultraviolet light would be rare because the very high pressures are rarer. So just like the amount of the Earth that is the crust in volume is much higher as a volume than the core of the Earth that's under very high pressure and is liquid. So the high pressure zones are rarer than the low pressure zones. There's a lot more low pressure zones than there are high pressure zones. Low by high, but not very high. So the higher you go in pressure, the more rare it would be. It's more rare to have electrons right next to each other than it is to have electrons this far apart. Okay, they're more likely to be this far apart than they are to be this far apart. All right. What would be light's equivalent of hydrogen? Again, it'd be a single photon. A single element of a photon, which would be like a graviton or whatever you want to call it. But I mean, that would be its hydrogen is just a single bit of momentum moving the speed of light with no frequency, no partners. Frequency is a group thing. Okay, it's like waves. Waves are a consequence of group behavior. It's something you analyze what a group of stuff can do. They can wave. A single thing can't be a group, so it can't do the wave thing, and it can't do the this and that. There's lots of things it can't do. Alright, the smallest frequencies, maybe even the most abundant, and could it be the main sole gravity causer? Well, again, it's all one force. I mean, I did say that in my videos. I mean, I had the one field theory. It's all one field. It's all one force. You can segregate it for electron force, proton force, red, black force, however you want to look at it, and creating charge and magnetism, or you can have the stuff move at a frequency, the black force, the electron force, and affect electrons with it. So the electromagnetic spectrum is only relevant because of the way it affects electrons. That's why we pay attention to it, because it has the capacity to push an electron out of its tension by hitting it fast enough and repeatedly to get it out of its tension, to knock it a distance. What are your thoughts about the functionality of Ronin coil? Well, I don't know, so I'll have to look that up sometime. Blah, 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 blah. Let me just copy it for future reference, I suppose. It sounds like something stupid. I'm just saying some Dyson thing or some, it's like saying the Wheeler phenomenon. Yeah, it's probably something stupid. Do you accept the notion of fields existing in nature and permeating the entire universe? The fields are made of something. That's the point. It's fields of. So it's like you can have a wave of soldiers. You can have a field of corn. You can have It's something, okay? So the field is little bits moving the speed of light. Some of the little bits are at a frequency so we can see them. Some little bits are in clumps of red or clumps of black. Alright, the straight line always works as a solution. What in the hell does that even mean? You don't understand what a straight line force, okay? There's a difference between some dopey notion that stuff can go around and create pressure on the other side. So if I put something in the way of something, the shadow of straight lines creates a shadow. If the lines can bend, then there's no shadow, right? I mean, it's that kind of easy thing to understand. And it also creates the convergence thing, the idea that it's all radiating from one point. But I don't, what can I tell you? There's a difference between understanding something. Maxwell's drawings are drawings of a straight line force. The lines of force, not the field lines, the lines of force are straight lines radiating perpendicular to the lines of force. The field lines. A moving charge, such as an electron, will produce a magnetic field. Again, just see that they just keep doing it. So because they said something stupid, you know, we're stuck with it forever. This stupid notion that somehow electrons, when you move them, they do something different. They're not doing anything different. You're just moving where the electron is. If there's a proton here and there's an electron here, and you're looking down at that, it's going to look different than when the electron's over here and the proton's over here. Well, now you're going to see something different, aren't you? Then you're going to see something completely different when the electron's behind the proton, aren't you? That's the difference. That's the change in the field that happens when the electron is moving. So when the electron is moving, what you see is changing. So if I had a little electron right here in front of you and I'm moving it back and forth, right? You could sort of understand that when the electron is right here in the middle, you're not going to see much of my face. But when it's over here, you see me. When it's over here, you see me. You don't see me here, you don't see me. It's changing the field by moving. It's changing what you see. If you're an observer looking at it, you changes what it looks like when the electron moves, because now you see more or less of the proton. You dumb fucks. If I had a magnet, okay, a red end and a black end, you can understand that I can put it in positions where you will have completely opposite reactions. If you were the negative, you know, if you were an electron, you could understand that when the magnet's pointed this way, it's attractive, and when it's pointed that way, it's repulsive, and you know, you can get that, can't you? The movement isn't radiating, isn't creating the north pole of the magnet. No, you're just moving the north pole of the magnet where it affects me and where it doesn't affect me. Shit. Okay, anyway, a moving charge will produce a magnetic field. Yeah, it'll reveal the dipole. And the reverse is also true. Well, whatever the reverse is. Moving a lamp is not what Professor Carroll said. That is what you said. Well, what I'm saying is the forces are emitted exactly the same way, and that's consistent with Maxwell's drawings. Maxwell's drawings are basically showing charges as light bulbs. And they're demonstrating that it's an inverse square law relationship between the charges, the divergence of the energy. It's exactly like if you just made the charges red light bulb and blue light bulb. So if I changed the idea of charge and I just said think about them as red light bulbs and blue light bulbs, and then you can see where the two forces mix, and the field line's going to be different than when the two forces aren't mixed. So where you see purple is going to be a weaker field than where you see pure blue or pure red. Alright. Your comments using a battery were confusing at best. Well, fuck you, and the ass till dead. Embarrassing juvenile at worst. Go fuck yourself. Dragging the CBR gave it all away. So the cosmic background radiation isn't to you something that's kind of curious. I mean, your Big Bang explanation of why it's there doesn't make any fucking sense at all, right? If there's an explosion and I'm supposed to think there's some sort of background radiation, well, where the fuck would it be? It's moving the speed of fucking light. How the fuck does it get to me? It should have gone way past me if there was an explosion, right? If there's an explosion and I'm on one of the slow bits that didn't get very far away, wouldn't the cosmic background radiation be off to, you know, lost in space by now? What the fuck is it bouncing off of, and how's it get to me? Dumb shit. You seriously believe that rambling on that rambling on randomly. So what the fuck? You got no evidence of this. Why don't you quote me, you pussy, you piece of fucking screaming pussy shit? Why don't you answer my question? How exactly is an electron doesn't fit the description of a magnetic monopole? How the fuck do electrons and protons not fit the description? Anyway, rapidly using sciencey words and concepts gives you credibility in what you say. No, I'm saying the arguments and the evidence are what gives me credibility. The fact that my fucking theory matches Maxwell's mathematics perfectly, all right, it's the drawings are right there in front of you, you know. And again, my statement is right here in front of you. Why don't you tell me how an electron and a proton put together next to each other doesn't perfectly define the smallest magnet you can make? If I put an electron and a proton right next to each other, haven't I created a fucking magnet, retard? I mean, you're this fucking stupid. What a circus act. You're a coward. You're a fucking coward. Why don't you answer one of my questions, you fucking coward? Ugh, God, these people are disgusting. Alright. Alright, so that's where we're done. Okay, cool. Fucking people. I hate this fucking planet of scuzzy pieces of shit. Jesus. People. Hate them. Mostly. Like I said, there's 10 of you I can tolerate, but the rest of you, you fucking can't get squished soon enough. You despicable, lazy, weak cowards.